Hi, in this video we will learn about a property of continuous functions on closed interval. This is the property given by intermediate value theorem. What it says is very natural, and let me just write down the conditions and the results. So I intermediate the value theorem says that suppose f is a continuous function on a closed interval a and b, and also suppose n is a number between f of a and f of b. It means what? It means that if f of a is less than f of b, then n is here, or the other way around, f of b is less than f of a, then n is between these two. Then there exists a number c in the open interval AB such that f of c is equal to n. What does this mean geometrically? It means that, okay, if you have a continuous function on an interval a and b, closed interval. Being continuous on closed interval means that if I start from one end of this graph, I can go in one move from one end to the other one without any need of taking off the pencil from the paper. I can do it at once. Then it says this is being continuous. Now assume that you have, this is f of a, this is f of b. Now it says that if n is any number between these two, say this is a number or this one, any number, then if you draw a horizontal line passing through n, it will at least intersect the graph of this function on this interval at least once. So here you see, now in this case, this is intersecting with the graph, and this is what C is. Well, it may intersect more than once, but well, what is guaranteed is just at least one. So here you can see there are more than one C's. Well, the theorem just guarantees one of them. This one also, C here. And in particular, if you take n equal to 0, if n is equal to 0, in other words, we assume that f is continuous on closed interval AB, and f of a, 0 is between f of a and f of b. It means what? It means that one of them is positive, one of them is negative. Yeah? So then there exists, well, let me write it, there exists a C in AB such that f of C is equal to 0. So it can be used, IV can be used to show that a function has a root unless interval, or an equation has a root in an interval. The condition, the way I wrote here, you may say, oh, do I need always f of b be positive, f of a negative? No, the other way around is also possible. The only thing here you need is basically when you multiply these two values, you get negative number. In other words, they have different signs. Being continuous and have different signs gives us what we have there. Okay, let's see an example of this. Example, show that the equation x cubed minus 2x plus 1 equal to 0 has a root in 1 and 3. Okay, this is minus, not plus. This is minus. Okay, so here we define f of x to be x cubed minus 2x minus 1. Yes, it is clearly continuous. Everywhere it is continuous. In particular, it is continuous on the closed interval 1 and 3. That's the first condition of IVT. We also need to check what is f of 1 and what is f of 3. If they have different roots, then we are in good shape. So f of 1 is 1 cubed minus 2 times 1 minus 1. This gives us negative, so this is a negative number. F of 3 is 3 cubed minus 2 times 3 minus 1. And this is negative 7, and that's 27. So this will be 20. And obviously this is a positive number. Negative, positive. It is continuous. As a result, there exists a number C in the interval 1, 3 such that f at C is equal to 0. Or f at C equal to 0 means what? C cubed minus 2C minus 1 is equal to 0. And that means that C is a root for the equation. Let us do another example. Show that the equation 4 to the power x equals to 5 minus 3x has at least has a solution. Has a solution on the real line. Well, I didn't even write down the equation. The domain, we have to make the domain ourselves. Okay, here, first make a function out of this. So bring everything one side. So f of x is equal to 4 to the power x minus 5 plus 3x. Well, again, this is continuous. This is exponential continuous. This polynomial continuous. So it is continuous everywhere on all intervals a and b. And now we have to find two values of x such that when we plug into f, they will give us numbers with different signs. For example, if we set one of these to be 0, we get 4 to the power 0 minus 5 plus 3 times 0. This is what? Negative 4, and it is negative number. What else? Okay, I can test another number. For example, do you think negative 1 is good? So if I plug negative 1, 4 to the power negative 1 minus 5 minus 3. This is definitely another negative number. I don't like negative 1 because the other one that I'm looking for needs to be positive. Needs to have positive value when you plug in into f. How about 1? So if I plug in 1, this is 4 minus 5 plus 3. Well, this is 7 minus, this is 2. This is positive. So function is continuous on any interval. Now I can make it very specific. On the interval 0 to 1, f of 0 is negative, f of 1 is positive. As a result of I, V, T, there exists C in this interval such that f of c is equal to 0. And f of c being equal to 0 means what? Means that 4 to the power c minus 5 plus 3 times c is equal to 0 for some c in the interval 0, 1. And that is the solution, the root we were looking for, 5 minus 3c. And you see, well, it has, you have to be careful. Being continuity is very important for this theorem to be true, and also being continuous on a closed interval is important. The same fact, you may not be able to make sense of the same fact if you don't force the function be continuous on the whole interval.